Today, we are finding the rate of change in context. And usually when it says in context, that means there's some kind of situation or story. The rate of change is a ratio, hence the word rate, that compares how much the second quantity has changed with how much the first quantity has changed. This is usually done from one measurement to the next. And hopefully it'll make more sense as we say it in fewer words. The unit rate compared the quantities of one single measurement. Y over X was the fraction that we used to do that. The rate of change is a little different. It compares how much the quantities have changed from one measurement to the next. So what that tells me is that rather than taking a measurement one time, you need at least two. Our rate of change is the change in the second quantity over the change in the first quantity. And if it's a little easier, you can remember that your second quantity is Y and your second quantity is X. Your first quantity is X. And to say change, mathematicians use a little triangle. They're super lazy. So this is the rate of change. It's change in Y over change in X. So the formula looks similar, but it is a little different from what unit rate was. Let's go ahead and see our rate of change in action. We're going to go ahead and do example 2 together. You are a complete math nerd and you are on vacation with your friend's family. Your friend's dad says that he never goes over 75 miles per hour. I don't know if I believe that. You decide to check to make sure by asking him how many miles you have traveled since you started your trip. You then compute the rate of change since you last asked. Let's go ahead and write our formula for rate of change. It was change in Y over change in X. I'm going to write that up here so that we can refer back to it. All right, let's go figure this out. So for our first rate of change, it already says not applicable, because if you were to look and say, how much has it changed right now that we're at hour 0? Well, it hasn't changed because we don't have an hour before that. So let's go to our next box and work from there. Okay, now how much have the miles changed? From 0 to 60, it went up and it went up 60. That was how much it changed. Pretty easy. This one is actually going to look pretty much the same. This one went up 1. So even though these numbers are the same, they do get different at some point. So I'm going to go ahead and write my fraction, change in Y over change in X. Ooh, how do I figure out which one's Y and which one is X? Usually X is on the left and Y is on the right, so you can frequently just write them that way. But it might help you to remember that the X is the independent variable and Y is the dependent variable. And so this column that you write X over should be the thing that doesn't depend on the other thing. Time never depends on anything. It just goes on and on and on, right? But the number of miles you travel does depend on time, so it's going to be Y. Okay, let's do our change in Y over change in X. It'll be 60 over 1, which divides out to just be 60. We do need to write our units, though. So just like our unit rate, our units will read Y per X, which in this case, our Y quantity was miles, and our X quantity was hours. So this is 60 miles per hour. Friend's dad, doing a great job, didn't go over 75 miles per hour. Let's check the next time we ask. So from here to here, we know we went up, but it might be hard for you to think how many miles you went up. So you can figure this out by subtracting 210 minus 60. Let's go ahead and do that over here. 210 minus 60. 150. So this went up 150 miles. And then on the other side, it went up 2 hours. Now, hopefully you know from 1 to 3 it went up 2, but you could find that out by going 3 minus 1 and figure out what that number is. Okay, we're going to go ahead and make our fraction. Change in Y over change in X. And which one goes on top? 150. So 150 over 2, when I divide that, I get 75 miles per hour. He's going a little faster, but as far as we know, he hasn't gone faster than 75 miles per hour yet. Now let's figure out for these next 3 hours. How far did he go? I know he went up. I hope he's going more miles from the beginning of the trip. Wouldn't that be sad if you just went backwards? 450 minus 210. 450 minus 210. 240. Now, if you can't remember which one to subtract from the other one, let me show you a trick. We have already determined that it went up. If we swap the numbers, you get the same number, just negative. So it doesn't matter the order you put in as long as you know if it's negative or positive. So I look at this and I go, well, I knew it went up, so it's going to be 240. Now let's do our change in y over change in x. And we put 240 on top and 3 on the bottom. 240 divided by 3 is 80. He started going faster. So, caught you, friend's dad. You lied. You went over 75 miles. Maybe he just wasn't looking at the speedometer at that point. Now, let's check with our unit rate. Would we have found out the same information? Let's just go to hour 6, and we're going to put y over x. So we're just going to put 450 over 6. When I divide 450 by 6, I get 75 miles per hour. So which one's right? Well, he did go 80 miles per hour for these 3 hours. So he did go 80 miles per hour for 3 hours. Well, an average of that. This measurement talks about how much he was going if you averaged out all 6 hours. But he said he never goes over 75 miles per hour, so that tells me that he's probably wrong on those last 3 hours. So our rate of change gives us better information about things like speed and different rates that change than unit rate does. Let's go ahead and do this one. Sometimes you have to make the table yourself. Courtney is collecting coins. She has 12 coins already, and she decides to add 2 coins each week. Create a table of values showing how many coins she has over a 5-week period. Start at week 0. It always starts at week 0. If it doesn't tell you a week to start with or a day to start with 0, and then put the number that the person is starting with. All right, we are going to write 1, 2, 3, 4, 5 on this one because it said for 5 weeks. So that makes sense. Then she adds 2 coins each week. So that tells me she has 14 now, then 16, then 18, then 20, then 22. Okay, for our rate of change, we're going to write change in y over change in x. My first one, remember, I can't find because there's nothing before that. So let's go ahead and find it for my second one, which is week 1. So which one's x and which one's y? Well, if you write xy just like that, you're right. But how many coins she has depends on which week it is. So it does make sense that coins is your y. Okay. From 12 to 14, we went up 2. And from 0 to 1, we went up 1. My change in y over change in x is 2 over 1, which divides out to 2. And you need to write the units. So it's going to be y per x, so coins per week. Okay, then this one's actually really boring because it just does this the whole way. So each one you're going to find that it's going to get 2 over 1, which equals 2. Now, if you're having, for some reason, your brain has died, if you know this is plus but you can't figure out the number, remember that you can put it in your calculator by subtracting 18 minus 16. Or as long as you know that it's plus and not negative, you could put 16 minus 18 and you'd be fine. So we get 2 and we get 1. 2 over 1. 2 coins per week. And I'm going to, it's the same through the whole thing. So we're just going to go ahead and fill these in. This one had the same rate of change the whole time. Now if you look, was 2 anywhere in the problem? Sorry, excuse me. Where'd it go? Okay, was 2 anywhere in the problem? Well, if you notice, 2 is right here, and it actually told you coins each week. Couldn't you say each by saying per? So that gives you a clue in the problem that that would be the rate. And if it didn't change, that's your rate of change.